Hey, everyone. Thanks for joining us today. Gonna give a little talk on AI and computer vision. Some cool stuff to share with you. See, we've got people trickling in now. Anybody that joins late can also watch from the beginning. And if you have to drop out, this recording will be available immediately after the webcast at the same link that you signed in for. So if you get a call or something, don't worry, just pause it or come back later. All right, let's get underway. Since the people that showed up on time, we don't want to waste their time. Let's dive in. Most computer vision's projects stall on two things. First of all, messy data, and second of all, unclear success metrics. So in the next 30 minutes, I'll show you the delivery loop we use to move computer vision from pilot to production, plus a few case studies and a checklist you can take with you later. My name's Chris Howard. I'm the founder and CEO at Softeq. We build edge AI hardware and software systems for Fortune 500s and startups, especially where cameras and sensors and on-device machine learning meet the real world. Across the industry, AI-based visual inspection has demonstrated up to 90% better defect detection versus human inspection. All of you know that the computers are much better at spell checking than we are, right? So the same is true for a lot of different things. So when the data and metrics are right, like in pharma and manufacturing, there's a study recently by Agilent's Lighthouse site that reported a 49% defect rate reduction in just under 4 months, and with a 35% product quality and 44% productivity and 48% output, all great big numbers, right? I mean, essentially about 50% improvement after deploying a computer vision toolkit alongside other AI and industrial IoT use cases. So today I'll focus on what makes results like these repeatable. So let's get going. By the way, I do want to note, if you look over on the side, there is an ongoing chat that you can use. You can introduce yourself. You can ask other questions. There's a QA icon as well. There will be a QA at the end of this presentation. So ask your questions over there, and then other people can upvote them as needed, and we'll answer the ones that are the most popular first. So go ahead and input your questions anytime during this podcast. You will, or webinar, sorry. It's my podcast showing through. Anytime during the webinar, it won't interrupt me, and we'll go and look at them later. So the agenda, as I mentioned, why CV now? What market drivers are pushing computer vision forward and what the benefits are. This delivery loop that I'm talking about, how we deliver AI and ML solutions. Case studies, I'm going to walk through 4 quick high-level case studies to kind of show you, get you an idea, get your own brain juices flowing about what might be possible with your own businesses and your own projects. A little bit about risk monitoring, how to get started, and like I said, a Q&A session at the end. We'll answer questions as we have time. Okay. Moving forward. So why computer vision now? Well, stuff has come down a lot in cost. There's low-cost sensors now. There's better tool chains. There's on-device compute, which is the edge AI that some of you might have been hearing about. You don't have for everything. Privacy regulations have gotten better defined, and the stuff just works now. I mean, I've been in this industry for 40 plus years and been hearing about AI for a long time, and it was all pretty much just talk. And I always joke about how my Alexa is dumber than a stone, right? So I new AI tools out there like Perplexity and ChatGPT and some of the others out there are actually really, really good. And so they're not only good, they've got low latency and they're reliable, right? And they have an immediate, or very short time frame for an ROI. So you can actually, get a return on your investment within many times 3 to 4 months. I know some of these slides have a lot of detail on here. Since you can go back and look at this presentation later, I felt like putting more here than less, and just having high level, 3-word slides would it would be better to have more than less. So don't feel like you need to read everything here, because you can reference it later, and we'll send you a link for that. So the delivery loop. So what we do when we start a computer vision project, we follow this loop. So first, of course, is framing the problem. Really need to spend some time here defining clear success metrics and business KPIs before any of that technical work begins. There's plenty of time to implement the solution. You really need to, build that solid foundation before you just dive into the technical problem. Then there's the data operations. A lot of people want to implement AI. You can't do much with AI without data. So oftentimes when we come in, the first step is, where's the data? Is it organized? Are you collecting it? If you have, maybe you have an AI project in mind in the future, well, you need to make sure your apps and your websites are collecting data in a way that the AI can use it, and then you can, use it to draw inferences from. Um, the baseline model. What are we going to use, right? Are we going to use a light touch computer vision? Are we going to go a little bit deeper into deep learning? Can we do it at the edge within, at the device, or are we going to need the cloud? Evaluation. We can do that before we even do a lot of this other work. Is it going to work? What are we going to get out of it? Once we get all that in place, we deploy it. Then you need to monitor it, and then you iterate on that, and then you're off to the races. Okay, data strategy, right? You don't want to do all this and have to rework everything, right? So I picked 4 domains to just talk about briefly, about what that means. Medical, for example, you've got a lot of variable lighting, a lot of occlusions, a lot of staff and patient monitoring. You've got to implement, within the hospital setting, Wi-Fi and security, and a lot of other integration and things like that. So you also have to deal with privacy concerns, right? How do you collect this data without getting personal information? And one of the ways we do that, for example, is by occluding the face in the video, because often it's not really important who it is, but what they're doing, right? Rail, this is like a train scenario, right? You've got a lot of crowded scenes, a lot of changing bag ownership. You've got multiple cameras you need to integrate. You've got person-object linkage that you need to work through. You also have public privacy concerns, but again, it's what you're trying to track is the actual luggage, and what's happening to it, right? If someone's stealing the luggage, what's the traveling of that bag, and associating that with a particular user, but you don't need to know who that person is. Automotive, most people know about the AI and self-driving. A lot of cars have it. Tesla's been doing it for quite a long time. But you've got a lot of cameras that you need to integrate. You need to do a lot of object classification. You need to have driver consent. So there's some concerns you need to take into account before you start implementing something. And then sports, which is always a fun one. You've got motion blur, you've got uniform similarities. Everybody looks the same. I know when I go to my grandkids' events, especially when they're in a uniform, they got the same hats on. It's a challenge to understand who's who, right? So you need to take that into account. And then you've got event logs and athlete consent. Maybe it's something they have to wear. Obviously they're sensitive about their own performance and how they're doing. So anyway, a lot of things to consider. So here is, there's a lot of things you can do with what we call classical, computer vision, or lightweight AI. So a lot of this is maybe something that you've already seen and familiar with. It's feature detection, face detection, simple kinematics, things that really don't involve a lot of AI, but you can do a lot of that at the edge, and sometimes not spend the money on doing something that's much more deeper when you don't really need it, right? So you really want to understand, what are you trying to do? You're just trying to detect the presence of a bag. Well, you don't need a lot of smarts to do that. You just need to identify the bag, and then you don't need a lot of AI in the cloud in order to process it. You don't need to know what kind of bag it is, etc. Right? So you have that classical computer vision, then you have lightweight deep learning, right? So you're doing some maybe more advanced object detection. Maybe if you're doing injury or risk, you're doing some rules-based analysis. Maybe you're trying to keep factory workers out of a certain area that they might get whacked by a robotic arm. Uh, and you don't need a lot of deep learning, but you just need to, you know, um, know a little bit more about your environment. And then the last one is heavy deep learning, right? So basically there it's preferable to try to do some of that at the edge for some situations. Some you might need to upload it to the cloud, right? In order to do the AI there. The advantage of course, of also doing it at the edge with these faster and faster processors is it's a lot less data to upload. As you can imagine, uploading all the video data for processing in the cloud is going to take a lot of time and effort. But if you can do the template analysis and the object detection, and then only upload the data, you can have oftentimes 10% of the data upload. So the point here is start simple, then add the intelligence, and then add the scale strategy. That's something you need to consider when you're doing these projects. So how do you evaluate it? I mean, like the slide says here, technical accuracy means nothing if it doesn't actually translate to business value. So you really want to understand what the business value of the AI is and what you're trying to implement versus, just implementing something cool, right? Medical monitoring has its own KPIs. You need to understand how fast you need to react to an alarm. What's the median, time to an alert. What's your tolerance on privacy incidences? Obviously, you want to have zero tolerance on that. So, and each domain has a separate set there, and that's my point mainly on this slide. So the critical success factor is, really identifying those minimum acceptable performance thresholds during the problem framing, right? You really want to know where you're going so that you can make sure you're using the right model and the right criteria and the right framework. Okay, so let's talk about a few cool case studies, and these are all projects that Softeq has worked on in the past. One is precision patient monitoring. Hospitals are really interested in what's going on in the patient room. What are the nurses doing? Are the devices deployed properly? Are they hooked up properly? They're also interested in what's going on in the surgery room. How long does the surgery take? What happens when there's an event? How long are people in the room and out of the room? There's a lot of things that hospitals want to know that can improve patient outcomes. So in this case, the challenge is, if you've ever, I'm sure most of you have been in a hospital room, there's a lot of complicated stuff moving around. It's not just like detecting a person that's going by a car. You're trying to figure out what's hooked up to the patient. Is it hooked up properly? Has it been checked lately? Right? And then there's the blurring of the faces, and there's the business KPIs of how quickly you need to respond to these events, and how do you collect that data and then provide it back to the hospital in a meaningful way. And then, given all of the things that could occlude the vision, how do you get around that? How many cameras can you have in the room? How many cameras should you have in the room, right? So it's, how long should you retain that data? It's a pretty cool application, actually. And I can't really tell you who that was or go into too much detail on these because obviously we have IP to protect on the clients. Another one, theft in transit. I talked about, trains. Basically, how do you detect luggage? They're not really monitoring luggage, but people are maybe stealing off of the train. So how do you monitor that? How are you looking for whether people are taking their bags or not? Maybe it's the same people that are stealing the luggage, every day, right? So you want to have a solution with real-time monitoring, intelligent alerts, reactive responses, and also the other challenges of this train is moving, right? And so you've got Wi-Fi and data and different environments and things like that, different challenges to go over. So again, I won't go into these like super deep, but just giving you an idea of what's possible nowadays. This particular client wanted to reduce, and deter, theft at passenger luggage racks, right? Because they want more people riding the train without having to fear about losing their luggage. So um, need to have a multi-stage detection pipeline, right? Detect the person, detect the bag, detect the object, associate the person with their bag, and then monitor that while they're on that train until they take their luggage back. And all this has to be implemented both on the edge and on the back end. And defining those KPIs, like I said earlier, in that workflow, how many false alerts do we want to have, right? Because you don't want to overwhelm the train staff with, a dozen false alarms on, someone stealing a bag when it's really just their bag, right? How fast do they want to get alerted? Is it within 60 seconds? Is it within 5 minutes, right? Maybe it is longer because the train isn't going to really, reach its destination, within a minute, right? And then again, there's privacy and ethics controls that you need to build in. How long do you retain that data? What is that human AI loop for the alert? And you need to plan that out ahead of time as well. Another case study here, we're developing an advanced driver assistance system, or what they call an ADAS. This is your classical, self-driving system, but in this case, they also had a particular eye on safety, right? So, and quite a few systems on the vehicle, and we had to implement this system using the on-vehicle sensors, both the cameras and the computing platforms, right? So mission critical objectives are like, how do we make driving significantly safer, right? How do we provide alerts in the vehicle to the driver? How do you prevent accidents before they happen, right? How do you monitor for weather conditions? How do you integrate 15 cameras plus, the 4 or 5, ARM-based processors that are on the vehicle in order to develop this solution? So this was a pretty fun project. You can dig down into the detail a little bit later. Last case study I want to talk about is sports tech, right? There's a lot of AI going on and a lot of tech going into sports tech. In fact, Houston in particular has a domain in sports tech. A lot of startups here are working in this particular domain. So it's essentially you're trying to take all that video that happens at the events, and then also during training camps, etc., and do more precise athlete monitoring and real-time indexing. You can do pose detection. You can do things like, even on wearables where you're trying to make sure you have the right form so you don't get injured while you're doing weightlifting. But again, you've got, to address production risks and ethical considerations and how you do comprehensive monitoring as you scale these systems, right? So, in sports, it can be performance tracking, it can be risk detection, it can be, health and mitigation, prediction. We've done, wearable suits that are trying to figure out whether, why are you favoring your right leg, for example. We've done knee sleeves that do like continuous MRIs to try to, either help prevent knee injuries or help with knee recovery, right? So all of that is possible now. So not only can you do all this cloud analysis using, Gemini and Perplexity, etc., all the back-end tools from Amazon and Google, you can do a lot of edge AI work on the smart devices and IoT devices themselves. I'll just touch on, production risks and ethics, right? So there's a lot of technical risks, when you're doing these AI solutions due to, maybe lighting variations or equipment update, domain shifts, like, the team changes uniforms. There's, cybersecurity where you're trying to make sure that it can't be, intentionally, manipulated. There's model degradation over time, right, which may require retraining. There's privacy and ethics, which is very key, especially in the med tech world, but just in general. Um, you need to consider monitoring strategy where you're looking at new models that parallel production, and then sometimes maybe it's not appropriate to use computer vision, right? Because you can't really observe what's happening, and so you're not going to be able to get that data and make those decisions. Maybe it's life critical, where you don't have dual systems for backup. Maybe you just have insufficient data. So that's one other thing that comes out during that initial evaluation. So, but it's important to consider all these factors from day one, and the cost of adding observability after deployment is 10 times higher than building it in from the start. So, all right. So that's a lot of information fairly quickly. What I wanted to share is that we do have a computer vision pilot checklist. We'll share this with you, and everyone that registered had with your email with this checklist that we use. We also do have starter package options depending on where you're at in your journey. Whether you just need a data audit or a pilot program or edge assessment or some other bigger project that you need to transform with your computer vision. So you don't need to copy all this down. We'll make sure that we send that to you. Okay, so if you want more in-depth case studies, that round circle on the left is a link to our case study page, which does have a breakdown of additional AI and ML studies that we've worked on. Also, a shameless plug for my Forge in the Future podcast, where I have had a number of people that are doing and implementing AI in the real world. There's about 120 episodes there, so I'm sure there's some that will be relevant to your particular industry. And then I want to encourage everyone to, go ahead and connect with me on LinkedIn. I'm happy to help answer questions, learn more about what you're doing in your projects, and be helpful, in any way that I can, since I'm very passionate about entrepreneurship and business in general. And then lastly, Q&A. This is where everyone can learn from other people's questions that you have about, maybe how to get started in computer vision or AI with your own projects, and we can schedule a later session where we bring in one of our AI engineers to do a 20-minute evaluation with you or talk about your particular situation, which you can do on our website. So that's it for today. Let's see if we don't have any questions. So let me go ahead and just start with some that I think you might be asking. And if you have any, please go ahead and share. So one question, how much data do you really need for a computer vision pilot, right? So the short answer is you can start smart, not big. You don't need to have 10,000, 100,000 data points for a computer vision project. You can start with 200, 500. What we call a golden set that accurately reflects those real world situations, and then basically it's a proof of concept or an MVP. Does this work before you go on and maybe invest in the time, money, and effort in collecting a larger data set, right? I mean, it's one thing if you got 500,000 maybe dog collars out there and you want to figure out how to help your users have healthier dogs or alert them to things like their behavioral patterns, right? But the main thing is you want quality over quantity. So you want to focus on getting your data sets correct and your labeling definitions and your error levels well documented, and then expand from there from 500 to maybe 1,000 to 2,000 data sets after you've come up with your annotation guidelines and that you can show you're drawing the right conclusion. So you really want to spend 70% of your initial data budget on those diverse and edge cases. 30% on common scenarios, 70% on kind of those those edge cases that can be a challenge. And this approach will help you identify failure modes early on, when they are cheap to fix. Okay, next question. These are my questions, so I know the answers to them. Edge or cloud, right? Where should you run the inference for your AI projects? Well, you want to choose the edge when you need like ultra low latency, right? You want an alert that's going to happen under 200 milliseconds. You can't go to the cloud and come down again. You can't go up to the satellite and back down and get an answer that fast, right? Privacy sensitivity, that's another one. Like I talked about, you want to do the analysis, so you don't have to upload people's faces or maybe other details into the cloud. You're doing it on the edge, perhaps on the camera hardware itself, and then you can obfuscate details later and upload that. Plus, there might be remote locations that you just can't get to the cloud. If you're out in, well, I mean, I'm half a mile from I-10, and half the time my Wi-Fi doesn't want to work that well. So if you're out in the field, you're out on the water, you're out in the Texas hill country, you're not going to have the benefit. That's an easy answer. Like, which one should I use? Well, the one that's going to work is the one at the edge. The cloud is really good for those deeper, model training and large scale data analytics, and maybe video searching and indexing after the fact, if that's what you need that. There's a project that we did for the Women's Tennis Association. They had huge amounts of data that they're recording every single day, as you can imagine, like every tennis match that every woman has ever played. But now you want to know something about those. You want to search that data, and you want to know where a particular player played, or where they were, a particular event or a particular match point or a particular opponent. You're going to want to index that video. So, I mean, but the truth is most platforms use some kind of hybrid. You're going to do something on the edge and you can do something in the cloud, right? And that kind of architecture optimizes both, the performance part and the operational efficiency. So the answer is oftentimes both. Okay, next question. No one has any questions today. What metrics actually matter to the business beyond accuracy, right? So we touched on some of these earlier, but the accuracy doesn't pay the bills of the business, right? So why are you investing in this AI solution? It's not just to be the most accurate solution out there. You want to make sure you are looking at missed critical events. That matters. False alerts per hour. These my dad used to call them the computer's high-speed idiots, right? So they're capable of spitting out just a tremendous amount of data and error messages. So you don't want a bunch of false positives overwhelming your support staff. And then basically the system is crying wolf, and then people are ignoring it, right? The mean time to the alert, how fast do you need it? And then, what's something that we call first pass yield, which is the percentage of processes that, complete correctly without any intervention. Because that's really the one of the main goals is, how do I do this without getting somebody involved? How can I make this a system that the computer handles all of that on their own before having to escalate, like, for example, support concept like level 2 support. And then can you get your data without having to manually tag everything, right? So that's another main goal. Can you get 60% of the data, the tagging done without having to, have someone go in and say, this is a stop sign and this is a car and this is a child, and having to, draw the box and label it. So like I said earlier, basically a pre-commitment to performance thresholds, during that project initiation step really helps, define, how the approach is going to work and how we're going to implement your technical solution. I have some more questions, which I'll cover, and then we'll wrap up unless anybody has any other. Oh, there are some. Oh, that's the chat. Okay. So how do you handle privacy, right? And face recognition. I touched on this a little bit as well, but masking at the capture so the data doesn't even have the face course, that requires face detection and then obfuscation and then storing that video in the system. So the face is just not in the data at all, right? That's one way of handling something like that. And you're not going to run foul of GDPR if you can't even tell who it is, right? Storing just the metadata, not the video. So to the extent that you can process that video at the edge and then only upload or store that data that you've collected, if you don't need, the faces and the bodies or whatever, then you can, that's again another level of filtering where you don't have to worry about privacy and compliance. Retention limits, how long are you going to hold on to that data before you delete it? A lot of times you don't have to hold on to it for, more than a day or a week or a month, right? Just delete it. You don't want to keep it. Plus, cuts down on your Google or AWS storage costs. And then you can add some consent and whitelists as well. And then lastly, having that human review as a part of the process. Oh, here's one question. All right, let's just answer that one. Do you use your own engine or does the client need to provide their own? If yours, what do you use? Are you able to build greenfield or do you need the customer to have a baseline of tech stack in place? Well, we've really seen all of it, right? So, I mean, if someone already has the data in the tech stack, then we can certainly leverage that. We don't require it. We don't implement our own engine. Softeq doesn't have its own, say, computer vision engine, but we are familiar with a lot of the platforms that are out there and available now. So there's, all of the major Facebook, Amazon, Google, etc. have their own, both edge AI tools as well as AI in the cloud. So their platforms are something that we can leverage, and we are partners with all of those companies. And so what we can do is come in and understand what fits your needs the most. And if you're already a Google client, then let's use Google. If you're trying to figure out who to use, then we will give you the pros and cons of which one. We can certainly build greenfield. Our approach generally is what can we use off the shelf, and then what do we need to write from scratch. But we want to minimize, your costs. We don't want to, reinvent what Google has already spent millions of dollars to implement. And there's a lot of also second and third tier vendors in this space. There's a lot of edge AI out there. And there's even a term called AIoT, where there's platforms that are already set up to do data collection, or companies like Arduino, we're also a strong partner with, have systems already set up on the back end for doing a lot of the back end stuff that you might need to take advantage of, especially if you're doing version 1 and before things maybe get too big or scalable. You can always do a version 2 or a version 3 as you continue to refine the model. That's a good question. All right, and I know we're at 35 minutes or so I'll do one more question here. And again, if anybody wants to reach out to me directly on LinkedIn or send us a message on Softeq on our contact form, it's free to talk to us. We're happy to learn more about your project, answer questions you have. We're not going to start the billable shot clock or anything like that. We do want to. We're here to help. Last one that might be of interest to all of you. What's a realistic pilot timeline and investment, right? Of course, this can vary wildly, right? Depending on the complexity of the project. But, there are some predictable patterns, especially if you're doing, like I said, that first iteration with a smaller number of data sets. So generally, if you've got a data foundation, we can, do an audit and a golden set creation and get that done within a couple of weeks. So that's again, not something that's hugely complex, but it's a good time frame. Then there's the model development that we base on that. That can be another couple of weeks. Edge deployment for a proof of concept, another 3 to 5 weeks. where you're doing hardware integration, and then 6 to 8 weeks of validation and decision. This could be more for, maybe pre-production, proof of concept, MVP style. I mean, it's tough to get something out and done and in the enterprise in 8 weeks, but there's certainly possible for smaller, more targeted engagements. Your costs are mainly in like data labeling. So if you're already doing that, maybe you already have data sets, so that can be half of the cost of your project. There's cost for edge devices and system integration, and of course professional services, which is the part that we do, is often only 10 to 15% of your overall cost. Like I said, a small pilot could be anywhere from 50 to 100K. Maybe a department scale is you're running 150K to 300K. Enterprise is more like 500K to 2 million, depending on what you're trying to do. And then your ROI can typically be within the first 6 to 12 months. So but what's most important on those pilots is clearly defined success criteria, right? And having a realistic timeline. At Softeq, we've learned that if you do what you said, when you said, for how much you've said, the clients generally are pretty happy, and they come back to us for additional projects, which is why we've have customers that have been with us for 10, 15, 20, 25 years now. And that's generally all I have for today. Thank you very much for spending 30 minutes of your Wednesday afternoon with me. I'm happy to talk more one-on-one with you about your individual projects. Reach out to me on LinkedIn or through the company website, and we'll be happy to schedule a call with you. I believe we're going to follow up also with an email, so make that process easy, where you'll have that checklist and you'll have that link where you can schedule a 20-minute meetup according to your own schedule and availability. So thanks, everyone. I hope this was valuable to you. I'm looking forward to learning more about what you guys are working on and how Softeq can help.